All right, so here we have our environment, and let's just reproduce as much as possible of our previous code. So that is, let's get a file where we just train our model and outputs all the associated files. Let me install Firewrite. Let's call this train.py. So I'm just gonna copy this from before. Let's reuse as much as possible. So okay, so first we have loading our dataset. Let's just get this working properly. Oh, there. Okay, we can start running this on the side. This is basically loading our dataset. Again, this takes a little bit. This is fairly large, so what we're gonna do is we're just gonna do a sample 100, so that it actually doesn't take forever to run commands here. Again, this usually fails the first time. Okay, pandas is taking a little bit because it's a large library. Okay, then we got transformers, might take a little bit. And of course, I need to copy our dataset, so let's we have it there. Perfect. So it's like it learns a little bit, but there it is. And there we are. So there we have it, our data set, 10 samples, 100 samples, everything so far so good. The next step again is to generate features. So to generate features, what we're gonna do is this copy pasting is following what it looks. Who would have said that that's the hard part? So There you go. So we don't have the two divides. There. And now we can do this. Oh, this doesn't exist. This. We can change our embeddings. And this should be faster because we're just doing 100. So this is basically the code we already had. And for what remains, we're just gonna train on split and save the model. So once that finishes, we're gonna get this executed. We don't need this. So this is pretty much reproducing what we had before. It's just making sure we have all our code. And the next step we're going to do is we're going to start changing things to make sure that this works as a pipeline. And then we can train it online. So for that, we're going to have to make some changes. Okay, so let's just finish running this. Okay, there. So if you just want to take a look at the then show it there. And then we just split, train, predict, evaluate. And then we save all our models. Awesome. So now if we come here and we'll take a look at this, we see that we have our tokenizer, we have our model and BERT. So what do we need to do to make sure that this works as expected? The first thing we need to do is we need to change our code to work with paths and to save things to Google Cloud. So what we're going to do is we're going to do several things. First, we're going to create a zip of our file here. So let me do this separately. I'm going to come here, training, and then we're going to compress this. So now we have our zip file. So first thing we're going to do is we're going to come to Vertex. We're going to create a bucket. Movie reviews, classification, bucket. We're okay with multi-region. We're okay. Okay. Awesome. So we have our bucket. Now what we want to do is we want to upload the Vertex training review polarity. So now this file, our data set lives in GCP, and the first thing we need to do is we actually need to consume this from GCP instead of our local file system. So let's go ahead and do that. So let's come back here again. And what we need to change is basically this part of the code. We need to first download it. And for that, we can use the following code. We're going to define a function that downloads data from a bucket. Actually, what we're going to say here is let's download things from Google Cloud, import storage. So we need to define here bucket name. This we just got. This is our bucket name. Source below name. This is the name of our file, so that's review.zip, and then the destination file name. And for this, we want to use exactly. So this will run inside a Docker. So we want a path that it's basically fairly neutral, and it's an absolute path. So that should do it. So let's try to run this code. To run this code, we also would need to unzip this file. So to unzip this file, we need to use some additional code. Let me just write it here. There. So let's install the Google Cloud there. So that should work. Let me check on this. Okay, let's just let's try this again. Easy peasy. Okay. So let's go back. Lovely. So let's run this, and let's try to run this. Okay, so basically since that there's no credentials here there for me. So what we're gonna do is try to run this cloud auth login. Just log in here. Continue. Allow. And there we go. So let's try it once again. It's funny how I always forget how to say these things. I need to set this up. Okay. So let's go back. Let's do this again. Here we go. Okay. So let's try this again. Let's try this. Let's try this. Voila. Let's try this. And let's try this. Awesome. So we're actually now working with this data from GCP, which is amazing. Let's check that that's actually working. So let's do this. Let's remove review polarity. Let's remove the zip, and let's remove anything from the temp. And let's try again. Let's see if this works. Oops, that happens sometimes. There we go. Awesome. So the next step is actually we need to upload all these things into GCP, right? So we need the models to be uploaded as well. So we need to change this line. So let's assume we are already doing that. Everything works great. So how do we upload things now to GCP? Well, for that, let me copy some simple code here. We're just going to define this function here, and we're going to say upload data, bucket name, tokenizer, tokenizer, the data, fire.joblib, And here we're gonna run into a problem because tokenizer is a folder and bird is a folder, and so we cannot just upload them as they are. So we might need to zip them. So let's actually zip them first. Let's save this. Zip bird folder into bird.zip. This is not exactly what we want, but it's close enough. So we're going to replace bird with nicer. Let's see if this works. We have them there. And now we can do tokenizer.zip, .zip. This is bird.zip, and this is bird.zip. Let's see if this works. Awesome, that seems to be working fine. So we can go to here. We can refresh this and see that we have everything here. So this is pretty much what we need, and we have our model receiving the data from a bucket and uploading the model results after training to a bucket. So the thing is, how can we deploy this model as a pipeline? This is going to be a very simple pipeline, just one step. So let's get to it. What we're going to do is we're going to be using probably not the simplest way to define a pipeline using Kubeflow, but rather the more sort of robust and versatile way of doing it. And in later videos, we're going to explore the other methods. So what we need to do here is we need to define a pipeline. So a pipeline is a series of steps. In this case, it's just going to be one that executes in GCP. And we're going to use this cell language. So let me just go straight ahead and show you what this is going to look like. So we have our code here. Let's just quit this for a second, and let's wrap this into a Docker container. So when we define here a Dockerfile, we won't need this. We won't need this. This is just main. This is just main. And that's pretty much it. So what we can do now is we can build this file. This is docker build -t train vertex. Nothing fancy here. This might fail because I never run in Docker there when I start. So this should be doing wonders. Okay. We call our file train. Okay. let's just build that. And awesome, it was built. This was very fast because I had built this before and I didn't change the layer with the pip installs, which is probably the longest running one. So what we can try to do here is we can see if we can get this working, running now inside a Docker container. So so we have our image there. We can do docker run train vertex python train.py. And that's gonna fail. Why? Because it doesn't have the proper authentications to actually work properly. But we can get around that. We can basically share the credentials with the Docker. So if you recall, it might be here. We had this file here that had our credentials, so we're just going to use that in our Docker container. So we're going to create this Docker run, and what we're going to do is we're going to first mount this file. So this is going to go temp equals JSON. And then we're gonna set those credentials there. And now this is train, how do you call it? Train vertex. And the command is Python train.py. So let's see if this works. Docker run. Okay, so this is running. That's great. It's basically downloading all the model. This is interesting. Basically, it's downloading the bird weights. So it needs access to the internet, and it's running everything. So this will generate everything that it needs. And it should also upload things to Vertex. So let's do this quickly. Let's stop this for a second. And let's erase everything here but the dataset. So that doesn't exist there. And let's also delete things here. So as you can see, there's no data here. Let's remove BERT. tokenizer, tokenizer.zip, per.zip. Okay, so now let's actually run this. And if everything works as expected, we shouldn't see any artifacts generated here, and we should see everything uploaded on the web, on Vertex. So that's basically what we want. Awesome. So what other things we need to do here? Well, something we need to do is something we did last time. We need to generate an artifact registry and store it. So I gotta never type properly. So we are gonna create a new repository here for a Docker, and this is gonna be train in Vertex. Train in Vertex movie reviews. Region, we're gonna be using this one's carbon. Everything is the same. Okay. So one thing that we will be doing now is we need to push our Docker image up here, and we can do this while it runs locally. Yeah, that's still running. So let's go ahead and in here build, let's do the same thing we did last time. TCP image equals so we do Docker tag train the image, and then we do Docker push. Exactly. So let's build this. Should be the same, except that we're tagging and we're pushing. And of course it's gonna take a little bit, so I'm gonna keep that running on the side. So, okay. We are running our Docker locally. That's basically downloading everything, running and uploading all the artifacts to GCP. So once this is in GCP, that should behave the same way. We are uploading our Docker image to an artifact registry in Vertex, so that basically we can run the same container up there. And now we need to define a pipeline that is basically what has the information that this runs this way. So let's go ahead and let's create a pipeline. We can do it here. We're gonna call this pipeline.py. Let me go ahead and add what we need. So we're gonna be using Kubeflow. So this is imported from Kubeflow pipelines. And what we do here is we define components. So we do this by using a decorator, and then this is going to be train, nothing fancy here, and then this is pretty much what we need. This train and name tag doesn't work anymore. This image we're going to change in a second, and this is basically Python. The command is Python, and here the argument is train.py. we need to change this image to here. There, it's a large name, but that's it. Okay, so this worked. Let's just check that everything works as expected here. We have no data here, and if we go to storage, we have everything here. So that's working fine. Something to notice here, we were pushing our images, and I ran into this problem yesterday. I'm running on M1 Mac, and when I build for M1, but when I run things in GCP, those machines are not necessarily ARM, they are AMD most of the time. So if I just push my image, that image is compiled against my architecture. That's not the architecture, and that might actually cause the thing not to work. So yesterday I ran into this, it was failing with a very strange error, and it took me a while to debug. So keeping this in mind, the alternative, we're gonna look into this into a different video, is to basically build these images directly into GCP, which also makes things easier. So here, the way to fix this is we're gonna do -- platform. Let me quickly recall this, minus platform, Linux, MED 64. To do this, I'm gonna need to build again everything, and of course this is gonna take a little bit. It's particularly hard for it to build against a different platform. I mean, I did this yesterday, but it took a lot longer than it normally does. Okay, so that's done. So we were working on our pipeline here. So we define our components. A component is basically, in this case, a container that we say, okay, take this image and run this command. And this is one step of my pipeline. So the other thing I need to do is I need to actually define my pipeline. And for this, I'm gonna say train pipeline, and it runs the train. So that's it. That's just defining a Kubeflow pipeline. What we need to do now is we want to compile this pipeline. So we're gonna say mostly this. So this is my ML train pipeline, and the name I just want it to be ML train pipeline.yaml. Okay, so I need to install Kubeflow. And we are almost ready to roll. So now we can run our pipeline. Things that happen when you use auto-completion. When people tell you that Gen AI will solve all your problems, you might want to doubt them. Okay, so this created this file, train pipeline. And as you can see here, it basically lists the steps that we're gonna run is this Docker running this command here. Okay, we are ready to put everything together up in Vertex. So let's go back to Vertex. What we need to do here, we need to check that our Artifact Registry has our image. Should be there. Perfect. Now the other thing we need to do is we need to upload our pipeline. The clickly way of doing it is creating a repository. So here we say Q4 pipeline, train pipeline, region, northwest. And then just go ahead and create it. And train pipeline, we can upload here. Okay, yeah, perfect. So next step is let's just go and create a pipeline. So here in Vertex pipelines, we're gonna upload a pipeline, upload a new pipeline or component. We can have to select a repository, and we had created this beforehand. We're just gonna call it train pipeline, and now we get to upload a file, which is the file we just created. So that's it, we have a pipeline, and now we can create a run. So let me duplicate this for a second. Let me navigate to storage. And let's erase all these files here. So if this works, this should automatically create all these models, these train models here. Let's see if that works. Our pipeline has just one step, is this. So we can come here and say, okay, let's create a run. That's the name of a run. We're just gonna run it in a region. This is a one step. We want our service account. So if we don't configure this, so basically this is the service account that the container runs with. If we don't have this properly configured with proper access, this is gonna fail because it cannot access what it needs. We're gonna continue. This is the output directory. This is basically where all the artifacts are gonna be stored. We can just create here a folder train pipeline outputs. Select it and submit. All right, so now our pipeline should start running soon, and we'll see how that goes. Basically, whether it runs correctly, generates our artifacts in our storage, which is what we want, or whether it fails for whatever reason. Something interesting to note here is that our pipeline is very simple. It's just this one step, but we could have several steps, and these steps can do different things, not just training, but for example, creating an endpoint. So in the previous video, we showed how to upload a model and generate an endpoint. We could have a part of this pipeline to be deployed at endpoint, which is very useful because that means that the model trains and then you just deploy your endpoint. The other thing that you could do is you could have conditional rules. So for example, we are predicting the accuracy of this model here. And one thing we could do is say, okay, train the model run it on the evaluation set, and if the accuracy on that tested is greater than, let's say, 80%, then go ahead and deploy it and create an endpoint. But if it's not, then don't. And so that you can have like very automated pipelines that retrain when new data arrives, but only get deployed if certain conditions are met. So our pipeline is running. Remember, this took a little bit on our local machine, so we might expect this to take a little bit on. Okay, it failed. Lovely. Let's check the logs. Let's see if there's. This is the error that I was getting yesterday. This is the error that means this platform might be incompatible. But we seem to have solved that, so let's check this. We're building against platform AMD 64. This might be tricky. Let's inspect. This is what I have. Okay, so the architecture never actually updated, so that's a problem. We can see here the architecture says ARM64, but it should be AMD. So that's probably the problem. So let's build again. Okay, yeah. If you remember, I told you that this took forever, and well, this is basically this taking forever. When you build against a platform that's sort of different, it actually takes a long time, because it cannot use internal wheels. It needs to basically compile everything from scratch against that platform. All right, this could easily take 20 minutes. So what we're gonna do is we are probably gonna cut this in the middle and come back to the point where this actually is working again. All right, so we finished building our image against the correct target platform. The image was uploaded to GCP. And so let's go here. Let's quickly check on the Artifact Registry that the image was properly uploaded. And let's rerun this. Let's go back. This should have been uploaded in the last. Okay, just now, okay. And this is the latest, perfect. So this is what we want. Let's clone it. That's perfect. That's perfect. Okay. Let's see how this works for us this time. The only change between this one and the one that failed is that we rebuilt our Docker container to make sure that it's using the right platform. We actually never checked locally, but we can go ahead and do that. We can Docker inspect our image that it's called train Vertex, and let's look at the platform here. And here we see AMD. So hopefully, if this was the cause of our mistakes, this should be fixed and should be working soon. Unfortunately, there are things that there's nothing we can do but wait. So we wait and see that everything works. We're gonna go again and check the storage. Since the last run failed, we shouldn't expect to see anything here. Yeah, exactly. Okay. So let's see. Waiting mode on. Okay, so the pipeline succeeded. That's great. We can come here and check the bucket, and if everything was correct, we should see things here, but we don't. Oh, there they are. Fantastic. So we managed to train a model using a Vertex pipeline, using the more general container components. And this is basically the most flexible option. But as you saw, we ran into some issues because we needed to build Docker images, we needed to upload them. If we change the code, we need to rebuild the images. And so there are other ways of building pipelines that are maybe a bit simpler, and we're going to explore them in a future video. Thanks for joining.